No. We're just kind of bringing it back in and trying to reinforce. So we're on our recap sheet. And it's problem number 5. So we have an equation. And the question is, growth or decay? And I heard somebody say decay. Because 0.947 is less than 1. What is the percent growth or decay? The 1 minus 0.947 is what you say 0.053, which represents 5.3% decay. Everybody remember that? Okay, number 6. The population of athletes is given by this equation. This is a logistic equation. It's not an exponential. That's an exponential. All right, what is the initial population of athletes? How do we find the initial value? Plug in 0. So when I plug in 0, that is how you always find the initial value of any equation anywhere. We plug in 0. What is e to the 0? 1. So isn't this just 1,001 over 91? Which, is that something? Oh, this problem looks familiar.
Yeah, it does.
So the initial population was 11. What is the maximum population? Exactly. The maximum population is your limit to growth, which is your upper asymptote. Remember how it has 2 asymptotes? Just like this. It's this asymptote, and your limit to growth is right here, 1,001. When will there be 332 athletes in the city? Said equal to 332. And then we have 2 opportunities, 2 ways of solving. One way would be to graph this, and see where it goes. The other way, we're going to go ahead and do it algebraically. So what's our first step? We're going to do this algebraically, not by graphing. We're going to multiply this over to here, right? So we're going to have 332 plus 90 times 332, 29,880. Equal to 1,001. Is that okay with everybody? I brought this over and distributed it with 332. All right, now what? So 1,001 minus 332. So 29,880 e to the negative 0.3t equals 669. Not yet. There's one more thing I need to do before I outline both sides. What is that? No. I gotta divide. You gotta get rid of this number. Okay, always, always, always get rid of this coefficient. So e to the negative 0.3t equals 669 over 29,880. this will disappear. So negative 0.3t equals ln this fraction. And then divide by negative 0.3. How does that look? Does that look okay to everybody? Let's see if we can all get the same answer. I got 12.664 years. Did you? All right. So that's enough of that recap for today. Got one more problem. We'll get that next time. What we want to do now is get back to our notes and get this 3.5 going. That is a huge, oh my goodness. That is a huge section. All right, so last time we were together, I'm on page 36 of my notes, we had done A, B, C, and D. And as I recall, we were kind of on the roll, things were going great. Let's see if we can continue that. Step one. Divide by 2, very good, Jimmy. 125. Now this is a no calculator problem, which means what has to happen? These two have to have a common base. Can 125 be written as a power of 5? 5 to the third, 5 to the third. When in doubt, multiply. 5 times 5 times 5 is 125. And then, as soon as you get that 5 on both are powers of 5, then the equation becomes the exponents. So the answer is 9. Royce, you paying any attention at all, sweetheart?
Yeah.
Okay. All right. F. Here we go. So when you see step 1, divide by 2. Both are powers of 3. 9 is 3 squared. And 27 is 3 cubed. Right? If I don't have a calculator, they have to be written like this. That's going to happen if I don't have a calculator. It's the only way to do it. Once I make them both 3's, then my equation is the exponents. Now this is a distributive. Does that make sense to you? That's a distributive. So 2x plus 6 equals 3. I got negative 3/2. Did you? All right. Perfect. All right. G. Divided by 36. And what is special about 9 over 36? 1/4. why does that make my heart beat for joy? 1/4 is 1/2 squared. So 1/2 to the x over 4 equals 1/2 squared. Kids, they're all going to break that way. So yep, x over 4 equals 2 and x equals. Now, h is just a teensy bit. We're going to start exactly the same way though, because we cannot do the problem with that guy sitting there. So we're going to divide them out. That's just 9. And you have a 1/3 and you have a 9. In order to do the problem, those have to match. So what do you want to change them into? I would change them into 3s.
Yeah, can we do 3 squared?
I would change them into 3s. So this would be 3 squared. You don't have to. You have to make a match. To me, it just makes sense to use 3. What about 1/3?
Can we flip it and just put it to the
3 to the negative first. That's exactly what it is. 1/3 is 3 to the negative first, and 9 is 3 squared. Now my exponents are the equation, and x equals all right, try I with your partner. It's the last one like this. Let's see if we can come up with an answer to I. Anybody wants to come up, put that on the board while I take attendance, that would be great. Yeah, that'd be great.
How are you getting here? I got 30. You broke all yours. You broke all yours. You got 25. Like, cause I thought it was, I got 30. I thought it was 2.
So let's see what Michael gets. Michael got 30 also. all saying 30? How does that look to everybody?
Looks good to me.
30 looks good? Perfect. All right, we're still in the same section, but now we're switching gears. Thank you, Michael. Nicely done. Michael chose to divide by an 8. He could have multiplied both sides by 8. That's the same thing, right? It's the same thing. Okay, Jay, tell me the answer. Oh my goodness.
Oh, it's 7.
Doo-doo. Log base 7 of 49 equals x. Exactly. Your eyeballs see that, but your mind immediately goes here. That's what your mind says. 7 to the x equals 49. So the answer is the next one's 8, Michael says. 2 to the third equals x. Guys, loop-de-loo, it's essential to your life in mathematics. Loop-de-loo. So K says 2 to the third equals x. Do not be like afraid when you see the next one. It is a loop-de-loo problem. And it will say 4 to the second equals x plus 2. So 16 equals x plus 2 and x equals 14. Now, I'm going to have you guys come up and put M, N, and O on the board, but for N, what are you going to do as your first step? You're going to divide by 2. That number can't be there in any equation we're doing, okay, whether it's exponential or logarithm. Okay, so we got room for 3 problems up here, so I need somebody to do M, somebody else to do N, and somebody to do
doing? I'm doing M.
all right. The first one is
I'll do N.
squeeze in. If you got a bad marker, let's just finish it. I don't know.
Oh, let's read the second now. It's 8. The 1 minus the 8 is 7. Oh, it's 8. It's not negative. It's negative 8.
Jimmy, don't let them. Just keep working ahead.
I'm assuming you bring the negative 8.
Hey.
Boy bow, boy dip bow.
Oh.
Now, letter O, I don't know if you're there yet, but letter O has an additional complication. What do you think might be the very first thing to do with letter O?
Subtract the 6.
Subtract the 6.
That much.
Yeah. And then do your division. N, did you get 15 for N? Yep, perfect, beautiful. And then Mike got 32 for letter O. See some nods. Good, we got that under control. All those problems that we just did, we did without a calculator. We didn't need a calculator to do any of those. Now we do. So for number 2, let's all get our calculators out. You aren't too good to practice. I want everybody practicing because we want to make sure we can do this when the time comes. So before I erase all these, any question about MNO? Okay, let's look at the next problem then and figure out what makes it different. Because it looks the same.
Well, there's no log.
Well, but it looks like the ones at the top of the page. And I got a 6 hanging around here, so I'll divide by 6. Now here's where it's different. Because the problems we just got done doing, we could make both sides have the same base. So like this was a 4. If this were a 4, life would be perfect. But there's no way to make 2 and 3 powers of the same number. So when that happens, we take the logarithm of both sides. And then we recall from our conversation the other day that an exponent becomes a coefficient. So x plus 1 log 2 equals log 3. Right? And x plus 1 equals log 3 over log 2. Remember, log 2 is just a number. So I'm going to divide both sides by that. Does that make sense to everyone? And then to get my answer, I'll just take that fraction and subtract 1. Now, we're going to type that in. Log 3. If your calculator doesn't automatically close that parentheses, make sure you do. Log 3 divided by log 2, and then minus 1, I got 0.5850. Make sure you're practicing typing it in. Now, before we go to the next problem, I want you to retype this into your calculator, but instead of using log, use ln. Do ln3 divided by ln2, and then subtract 1. And what happens? It's the same thing. So the moral of the story is, when you take the logarithm of both sides, you can take whatever logarithm you want. In problem B, it will be handier to use an ln because the problem has an e in it already. Could I log this equation? Absolutely. I'm going to ln though because that's handier. But I can't do anything until I do what? Divide 17. If you don't divide, unless you know what you're doing, you're not going to get the right answer. And if you know what you're doing, it's going to add steps. So let's not. Let's just divide. Now, if I ln both sides, let's not skip steps. ln both sides. What happens right here? They're gone. When ln and b touch each other, they cancel. So x is ln 93/17. Type it in on the calculator. 1.6994. try C? All right, go for it. Try C on your own.
Skeletal. No.
Yeah.
Why?
Because she said,
How do you know if it's your fault?
If you're in the directions, I just it'll work.
So would you get points deducted?
What'd you guys get?
Negative 12.
Negative 12.3776. All right, here we go. D. We are not worried one bit because there's decimals no problem. Who cares, right? We have a calculator, so we'll go ahead and divide by 3. Now, can I LN both sides?
Good.
Can I log both sides?
Good.
There's no advantage to either one, right? Nothing's gonna cancel. It doesn't matter what you do. Take the logarithm of both sides, whichever one you prefer.
Oh, crap.
2.1447. All right, 2 more. 2 more. Go ahead and do them with your partner, with your answers. If you want to put them on the board, you can.
Ow!
Let's maintain self-control. Let's have someone do E and somebody else can do F. For F, you'll probably want to start by subtracting 10. Eli, calm down, sweetheart.
That. It's doing the same thing. You know that, right?
you do it your way, I'll do it mine. Just old.
I love that we're so enthused with one step.
Yeah, we'll do that. Yes, it is. That's exactly what you got. Negative 0.
Eli, what did you get for?
0.14. 0.0218 negative.
0.02.
That's what I
I got that.
No,
Look
it's
it.
not.
That's what I got.
Oh wait, I mean, oh no.
Ln 200
No, I
divided by
got
ln 200 divided by
Wait,
81. I got negative 0.0240.
I see your pile stuff.
I got negative 0.02.
Yeah, I got the same answer.
Alright, I'm having some consternation about problem B. Obviously, we're gonna start by dividing by 81. We'll take the natural logarithm of both sides, so 4x plus 1 equals ln 200 over 81. Now, I know I can type that right there into my calculator, but to get x, I'm gonna have to take that right there and subtract 1 from it. So ln 200 over 81 minus 1 is gonna be 4x. And then I have to take all of that and divide it by 4. So when I type that in, I'm gonna type ln 200 divided by 81. And I can look at equals if I'm more comfortable. And then minus 1 equals, and then divided by 4 equals. And the answer, I heard some of you have it, negative 0.0240. That is
I
right.
actually did that.
So if you didn't get that, and I know some of you didn't, you want to go back and make sure this is what you're telling your calculator to do. Did anybody get F?
Yeah.
3.3111?
Can you show how that?
Subtract 10, divide by 5,
I divided by 5.
log both sides.
Log 3 log 38 over log 3 x equals 3.31.
Alright, now we're gonna run into a couple of interesting problems here. But not this one. This one's pretty straightforward. It just has a little cleanup to do. So, this is problem 3A. What do you think I'll do first? Minus 3. Now, do not get ahead of yourself. When you minus 3 from both sides, this is negative 2, right? So I'm going to divide by negative 2. When I divide, nothing changes except that's gone now. So log base 6 x plus 2 equals negative 1. So listen again. Miles, you paying attention back there? What are you doing? Doing the problems? So I'm going to divide both sides by negative 2. Nothing changes. This stays exactly the same. Now I'll loop.
That's an airball.
What is 6 to the negative first? 1/6. So x plus 2 equals 1/6. So x equals 1/6 minus 2, which is either negative 1 5/6 or negative 11/6. Remember, you need a common denominator when you subtract. is exactly the same. Step one, we're gonna add 2. Then we'll divide by 3. Everybody good to here? Now what? Loop-de-loo, remembering that what's the base right here?
10.
No, no, no.
That's only long.
10 is the base on log. What's the base on ln? Guys, why do we use ln in E problems? Because the base is E. So there's an E here. So E to the second equals X. And that's my answer. Just leave it E to the second. Step 1. Subtract minus 2. Very carefully. Divide by -1. The base is 10, because that's a log. No. 10 to the -2 equals X plus 1. What is 10 to the -2? Well, it's 1/10 squared, which is 1/100. So X equals 1/100 minus 1, or -99 100ths.
Alright, yes.
Yeah, that's fine, but this would be a no calculator problem, so if you're just decimal, make sure you know the decimal.
Oh, it's
Yeah.
no calculator. It didn't say that.
I didn't know it did, you're right. But this would be a no calculator problem. Obviously, 0.99 negative is the same as that.
We're rewriting this before we start.
All right, now we're ready to mix it up a little bit. Let's stop right here, take a breath, we okay? What's going on here? All right, what is different about problem B? There's 2 logs. Now, you are wonderful students.
Yeah.
You cannot solve a logarithmic equation with 2 logarithms on the same side of the equation. This is impossible. I can't do it, you can't do it, we can't do it. The only thing we can do is condense it, so instead of having 2 logarithms, we only have 1, okay? So we are going to smush these together, so there is only 1 logarithm on that side of the equation. Now, we talked about how to do this the other day. When I want to put these 2 together, I have to pay attention to that right there. Because that tells me when I put them together, it's going to be a multiply. So in the parentheses is going to be x times x minus 3. These 2 things are going to be multiplied when I rewrite this with 1 logarithm. Okay? So I've got the log of x squared minus 3x equal to 1. What am I going to do with that? Loop-de-loo. The base is 10. So 10 to the first equals x squared minus 3x. set it equal to 0. X squared minus 3x minus 10 equals 0. Subtract that 10 over. Remember, 10 to the first is just 10. Then what? We could use the quadratic formula. We could also factor. Minus 5 plus 2, how does that sound?
Good.
So x equals 5, or x equals negative 2? Now, we're not done, believe it or not. We're not done.
What?
This one is extraneous. Why is that extraneous? Well, let's look back at our original problem. If I plug in negative 2, this would say the log of negative 2. What did we discover about taking the logarithm of negative numbers? Can't do it. If you forgot that, try it right now. Hit log negative 2, and it will give you an error. You cannot take the logarithm of a negative number. So that won't work. Negative 2. And the only answer to the problem is 5. Now, you guys, we need to talk about something here real quick, because too often, students will cross off every negative number they get. And that is not, the problem isn't that it's negative. The problem is, when I plug it into the equation, it means I'm taking the logarithm of the negative. Here's the difference. Let's suppose this had been the problem. It wasn't, but let's just suppose that it had been. Okay? Now, if I got negative 2 when I solved this, it would be okay. Because if I put negative 2 in, this number is still positive.
Yep.
That's the key. You see what I'm saying? Don't just cross off negatives, because sometimes negatives are okay. Okay. All right, let's do one more. You guys have been really good. Let's do one more. Actually, let's finish this page. So 2 more. No. Yeah, 2 more. 2 more. Come on. 2 more. All right, so here we go. Ready? Easy. Now, this problem is different than what we just did, because it has logarithms on both sides. That is actually easier. However, we still cannot have 2 on the same side. So these have to be condensed. Log base 7 of something. Now, this time when I put them together, because that's a minus, this time when I put them together, I'm going to put it together as a division. Everybody okay with this?
Yeah.
Now, I want you to use your logic. If the log of that equals the log of that, doesn't it make sense that that equals that? Now, some people say, I'm going to cancel the logs. That isn't really what's happening, but effectively that's what happens. Log equals log, they're gone, and just the numbers are equal to each other. So 2x equals 15, and x equals 15 halves. Perfect. Last problem. Very
Home
simple.
stretch.
Very simple. plus, this will be a multiply. Since I got logs on both sides, I can disregard them. And 4x equals x minus 2. So 3x equals negative 2. And x equals negative 2/3. Negative 2/3. Tom has no solution. You cannot take the logarithm of a negative number, and that's exactly what you would be doing right here. 3.5 due on Tuesday. 3.5 due on Tuesday. I know we have a couple of like really wild problems to do there. And we will do those, but they're not in your homework, so I want you to work on 3.5. I also have something to keep your mind busy if you're driving to Grandma's in the car and you don't have anything else to do. This is optional. Don't Google it. Work on it if you have time, and if you don't have time, go to recycle. Give it to your little brother. Play with. Give it a shot.
Yeah. I think it's like this. I don't understand what's happening.
I just wanna make sure one of y'all is lost.
No, put it in place.
What is
Nothing
this?
is lost.
I believe
It's
you.
something fun, a fun exercise for you to work on.
You just gave me math.
Yeah, because it is fun. Look, Charlie's already working on it.
I'm looking at it.
I'm gonna get back with you, Emily.
I took a peek at it.
Well, it's a problem.
Singing it in my ear. You didn't even hear half the time you said it. And then it's going, "You're 99."
That's tricky.
Anyways.